In this video, we're going to look at some Module 1 practice problems that you'll see at the end of the Module 1 notes, and I highly suggest that you complete those problems before watching my explanation here. Okay, let's get started. Number 1, describe the type of sample. Part A, a college faculty consists of 400 men and 250 women. The college administration wants to draw a sample of 65 faculty members to ask their opinions about a new parking fee. They draw a simple random sample of 40 men and another simple random sample of 25 women. And so it's tempting to say that this is a simple random sample, but it's a simple random sample within each group. And so overall, when you have a population and you are doing a simple random sample of some people from all groups, that is exactly what we call a stratified sample. So stratified is the best way to describe letter A. All right, part B. Officials at a local transit authority want to get input from people who use a certain bus route about a possible change in the schedule. They randomly select 5 buses during a certain week and poll all the riders on those buses about the change. So you can imagine that a local transit authority would have a whole fleet of buses. But what they're doing, instead of pulling some people from all of the buses, they're pulling all of the riders from just a handful of the buses. And so to contrast this with Part A, where we saw some people were being sampled from all groups, now we have all people being sampled from some groups. This is a cluster sample. Part C, police at a sobriety checkpoint pull over every 5th car to determine whether the driver is sober. There's a system to this method, and that makes this a systematic sample. And then Part D, 500 people attend a charity event, and each buys a raffle ticket. The 500 ticket stubs are put in a drum and mixed, and 10 of them are drawn. The 10 people whose tickets are drawn win a prize. And so what's key to recognize here is this is a lot like a lottery. Every person that's buying a lottery ticket or buying a raffle ticket has an equally likely chance of being chosen here, or of being part of the 10 people who win the prize. And so this is exactly what we would characterize as a simple random sample. And remember, the simple random sample is kind of the gold standard in statistics. Okay, let's take a look at some more questions. Number 2, let's describe the data as either qualitative or quantitative. And so Part A, your best friend's name. This is going to be qualitative. Clearly nothing numerical here, nothing countable or nothing measurable. It's going to be a word or a description, so qualitative. The number of touchdowns in a football game, definitely quantitative. And this is going to be quantitative because this is something that we can count or measure, do some math on, whether it be an average or something like that if we ever wanted to, find the average number of touchdowns in a football game, things like that. The title of the stats book. Again, it's going to be a word or a description or some sort of categorization. And so this is qualitative. The number of cars sold at a used car dealer last month. Again, this is something that you could see yourself doing some math on. This is a number, something that we're counting or measuring. So this would be quantitative. Number 3, determine whether the data are nominal or ordinal. So that means now we're just looking at some qualitative variables. So the categories here are strongly agree, neutral, disagree, or strongly disagree in a survey. Now, there's definitely a sense of order to these because when somebody says neutral, we're kind of putting that in perspective with what the other possibilities are when answering that survey. And so this would be ordinal. T-shirt sizes, small, medium, large, extra large, XXL, same thing. Whenever somebody responds with an XL or a large, it's relative to some of these other possible responses. And so this would again be ordinal. But the items on a pizza, pepperoni, mushrooms, green pepper, onions, there's really no sense of order to these possible responses, whether this be in a survey or anything else. There's no natural way of ranking pepperoni above green pepper or mushrooms above onions or anything like that. So this would be best described as nominal. Okay, so let's take a look at part D. Stats Exam 1 letter grades for a class of 30 students. Well, let's think about some possibilities here. You've got A's, B's, C's, and D's. And isn't there a matter of ranking going on here, kind of like what we saw in the t-shirts example with a small, medium, large, XL, or in the one before that? Like if somebody reports a grade of C, I'm thinking about that grade relative to some of these other possible grades. And so based upon this, I would say that letter grades would be an ordinal variable. Okay, let's take a look at the last question here. Which are discrete and which are continuous? So now we're talking about quantitative variables or quantitative data. The amount of caffeine in a cup of coffee. Now, a lot of times that is advertised as a whole number, but you probably don't have a whole number of milligrams of caffeine sitting in that cup of coffee. And so this is actually a really tough question to answer. I would almost say here that this is going to be based upon the data. And if the data that we're working with are whole numbers, then we would say that the amount of caffeine is discrete. But if the data are presented with fractional amounts of milligrams of caffeine or decimals, things like that, then we would say that the amount of caffeine would be a continuous variable. I would say that it's likely that this is going to be continuous, and that is because despite having a whole number of milligrams of caffeine often being reported as being in a cup of coffee, the actual amount of caffeine most likely is not that whole number. And so the amount of caffeine we're probably talking about includes fractions or includes decimals. The same kind of goes with the amount of charge in your cell phone. Once again, I'm going to say that the answer to this question is based upon the data. You know, if you look at the amount of charge that is left on your phone, like if I press my phone right now, it gives me a whole number percent. It does not give me any decimals. And so based upon that, it might make you believe that the amount of charge in your cell phone is discrete. But if I press my phone again after I just did, a few seconds ago, it's still showing the exact same charge as it did, 10, 20 seconds ago. But in reality, it has less charge as before. And so the phone is probably revealing to you the whole number percentage, but the actual percentage charge left in your cell phone probably does include some fractions or some decimals. And so since you likely would not be restricted to a whole number, I think that I could again say here that this is likely to be continuous, but again, it's based upon the data. If the data are showing us whole numbers, then we would suggest that the charge is a discrete quantitative variable. The number of people who attend your birthday party. Well, you can only have a whole number of people. You are restricted to a whole number of people in a case like this. So this would be discrete. And then the last one, the amount of time that you sleep, this would definitely be continuous. And the reason is very few people sleep for exactly a whole number of hours. Most people would sleep for 7.4 hours or 7.25, some sort of a fraction after that whole number or some sort of a decimal. So hopefully these examples help you out a little bit, and now you can tackle the Module 1 homework. Good luck.